The title of this video is Demonstration of Cognitive Device Management for Enabling Future Internet Scenarios. In this slide, the names of the authors and developers of this demonstration as well as their affiliations are presented. This demonstration focuses on self-optimization of cognitive devices. The corresponding cognitive device management functionality has been deployed on two types of off-the-shelf devices. The management functionality running on the devices comprises mechanisms for dynamically selecting the configuration of a device, taking into account user preferences, device environment characteristics, that is context, policies, and knowledge established through machine learning functionality. User preferences are mainly expressed through the so-called utility volume, which provides an indication of the user satisfaction associated with the use of a service at a particular quality level. This information is collected dynamically so as to update the user profile accordingly. The context refers to information on candidate networks or configurations in the area where the user device is located, as well as estimations on the typical capabilities of these networks or configurations obtained through learning functionality. Policies specify a set of rules that the device must follow. In this sense, policies can influence available services, quality of service levels, as well as the subset of available networks or configurations for the device. The implementation of the learning process is based on Bayesian statistics concepts. In the case of learning user preferences, the aim is to estimate the probability of the level of user satisfaction for a specific service and perceived quality of service level given a certain location and time zone. In other words, conditional probabilities for the utility value are calculated. In the case of learning context information, the aim is to estimate the most likely capabilities of candidate networks or configurations in terms of the quality of service levels that can be achieved. This estimation is realized through the use of conditional probabilities and the probability density function. These probabilities are updated each time the device obtains measurements from available networks. The decision process for selecting the optimal device configuration may be triggered either as a reaction to a situation currently encountered, such as degradation of the perceived quality of service or the identification of a configuration offering better performance possibilities, or in a proactive manner by making use of experience obtained over time. For the realization of the decision-making process, two cognitive, knowledge-based schemes have been devised. One is based on multiple attribute decision-making, referred to as cognitive MADM. The other scheme is a utility-based decision-making scheme, referred to as cognitive utility-based configuration selection. Furthermore, in order to obtain a better understanding of the performance of the cognitive device management functionality, for each of these two cognitive schemes, a corresponding legacy algorithm has also been implemented, namely a legacy MADM and a legacy utility-based algorithm. The legacy decision-making algorithms only exploit currently available information. They do not utilize any knowledge. In other words, the legacy decision-making algorithms simply select the network that offers the best quality of service level, combination of quality of service parameters at each moment, whereas the cognitive selection algorithms decide based on knowledge obtained through learning functionality. Now we will proceed with the demonstration of the implemented cognitive device management functionality. We have four devices, each running a different configuration selection scheme. The graphical user interface of each device allows us to monitor the processes of context acquisition, profile management, and policies retrieval. Through the Context Acquisition tab, it is possible to view information on available services, currently running services, available candidate networks in the area where the device is located, and some measurements on the currently operating network. Through the Profile Management tab, it is possible to view information for a specific user profile. The main parameter in the user profile is the utility volume, which indicates the user satisfaction associated with the use of a specific service at a specific quality of service level. Through the Policies tab, it is possible to view information on allowed quality of service levels and services for each of the networks available in the area where the device is located. As the devices move, context information on the available candidate networks is updated dynamically. The devices pause in an area where there are two wireless LAN configurations. All four devices start a specific service, and the management functionality on each device will select one of the two available wireless LAN networks. The selection is based on two quality of service parameters, namely the measured bit rate and the delay. For the bit rate, 6 reference values are considered, which are 6, 12, 24, 36, 48 and 54 Mbps. For the delay, 2 reference values are assumed, 2000 and 2500. In this scenario, initially, network 2, the blue network, is worse than network 1 in terms of provided bit rate, while for the rest of the simulation duration, network 2 is almost always better than network 1, steadily providing a bit rate of 24 Mbps after a certain point. As can be observed in the case of the legacy selection schemes, the selected configuration changes each time the measured bit rate changes, thus resulting in several reconfigurations of the device. More specifically, with the legacy selection schemes, the device switches network 3 times. On the other hand, with the cognitive configuration selection schemes, the selected configuration changes only once, after the outcome of the learning mechanisms indicates that network 2, the blue network, is more likely to achieve better quality of service levels than network 1, the red network. Therefore, by decreasing frequent unnecessary changes, the cognitive configuration selection schemes can increase the reliability of network selections. In the case of the cognitive utility-based selection scheme, user preferences are updated dynamically. When stopping a running service, the user is asked to evaluate how much he or she was satisfied from the obtained service. 5 rating options are provided. The user can also decline providing feedback by clicking on the Cancel button, in which case the profile information remains unchanged. In case the user does provide a rating, then the utility value corresponding to the most dominant quality of service level is updated. In this scenario, the dominant quality of service level, that is the one that is most frequently provided throughout service usage, is quality of service level 9. This corresponds to a bit rate equal to 24 Mbps and delay equal to 2500, and the associated utility value is 3. The user rates the service with excellent. This results in an update of the user profile, and the utility volume for quality of service level 9 becomes equal to 5. This higher utility value will drive the selection scheme to decide a change faster the next time this service is activated. This slide provides a list of references for further reading regarding cognitive device management functionality.